Hey guys, what's happening? So welcome to this video where we're going to discuss multimodal RAG systems. We're going to keep it really simple and more intuitive for everyone to understand why do we need multimodal RAG systems, how can we implement it, and what are some nuances needed to develop it well. Now, before we delve into it, what is multimodality? For those of us who don't understand it, multimodality in any system is where it's able to work with different modalities in which information is captured. Different modalities means text is a modality, audio is modality, image is a modality, video is a modality. So all of these have different ways in they capture information about anything that's basically happening around us or in a system. Now, a good retrieval system or a good information system should be able to work with all of these different modalities. This is how and why we are building the multimodal RAG systems. Now in this video, we're going to cover it across 4 different segments. Feel free to scroll through all of these through depending upon what might interest you or might bookmark it, come back to these things and just review it whenever you are building something. We're going to start off with why do we need multimodality in RAG systems? We are going to go into a bit of a deep dive into architectural consideration of a multimodal RAG system. Then we'll spend some time thinking of some design patterns that we see out in the wild and some successful design patterns that I have seen people implement and they're implementing multimodality in a RAG. And finally, we will build a multimodal RAG system right from scratch. And hopefully that should be really good. And yeah, let's go. Alrighty, so let's start with understanding the why behind why do we need multimodality in RAG system. The answer comes not just for RAG, but for any information system that exists today, whether it might be search, whether it might be simple retrieval system, whether it might be normal information with a person presenting to another person. It has been observed that any communication or any information is more effective. It's said to be it's around 66% more effective when you had multimodal information that is being shared, right? Like for example, when you're presenting someone, it's always good to share an image or a chart with the person so that they're able to understand what you're talking about rather than text only or just conversation only. So in that way, essentially, there have been multiple scientific experiments which actually tell us that a multimodal system or multimodal information system is much more effective in making a user happy or making the query answers to be more effective. It's said to be most of the information that exists on the internet and is being created today is not text. It's audio, it's video, it's image, it's probably sensor data, and so on and so forth. So when we are developing a RAG system, if we are just looking at text only, we are leaving lots of value on the table, right? Again, it differs a lot. There are some industries, let's say legal, probably banking, which are extremely text heavy. Okay, we probably won't find any image data in there. We will probably have some audio data from customer service, but still, all of those little bit of data that exist in there has lots of value in there. So a RAG system or any system essentially should always consider or try and be multimodal, so it's able to get value from all of these different modalities. Alrighty. So yeah, with that, let's move into understanding some of the architectural consideration of multimodal RAG system. Alrighty. So let's develop some intuitions around the architecture consideration that you will need when you are building a retrieval augmented generation system with multimodality at its core. Now, the first thing when you're building it, what I will suggest everyone to do it is just think of all the different modalities that you will probably have in your information capture within the business as documents, right? Like probably a text is a document, an image is also a document, a video is also a document when it's stored in a document retrieval system, and same is with any other modality that you can think of. Now, the biggest thing that you're building a retrieval system is you need to develop an index for your whole corpus, right? You need to have an index for your images, your audio, your video, and so on and so forth. So in that essence, there is not much of a difference between the overall system consideration between a text only or a unimodal system compared to a multimodal system. The difference comes in is different subsystems that we want to build properly so that different modalities can work together. Okay, let's look at this small architecture that I put up from this wonderful blog by Langchain. It's called Semi-Structured Multimodal RAG. Really great blog. I recommend everyone to read through it. Here, what they are kind of showing is if you have a document, right, and in this instance, is an academic paper, right? In that academic paper, there will be tables with structured information, there will be text, there will be images, right? Now, all of these three are different modalities, and all of these three will have its own context and own information that they're probably sharing with the user who is probably reading that paper. So to think of it, something that we have discussed before, one thing that needs to be done is indexing, right? And how do you do indexing is the main core of a multimodal system. Now, in essence, here what they're doing is they're just passing all of these three different modalities through an LLM, and it creates a summary for all of these three: images, tables, and text, and stores the summary in a vector store, and stores the corresponding and linking to that summary with an index into a doc store. Like, for example, if the summary is a picture of Mona Lisa, right? That's probably a summary, and it has, let's say, index of XYZ, and that corresponding index is actually stored in a doc store. So whenever someone refers to that particular summary, they can refer to that particular doc store, right? This one something to understand. Same thing with the table, right? You might have a table which might be different training data used for different large language models, and it might have that might be a summary for a table, and that table might be stored in a structured form into a different sequential table, right? Essentially. So that's about it, and how you might have to think of indexing different multimodal systems. Now, what happens in production is when a question goes out, right? When a question comes through a retrieval system, that question, similar to how we discussed in the retrieval system in one of our past videos, we have to find corresponding document chunks in our system, in our corpus, which is now multimodal, which could help answer the corresponding question or the corresponding information that is being seeked by the user. That's about it. And that question basically hits the vector store and tries to find the relevant summaries. And correspondingly, it actually sends the corresponding documents along with the summary to the large language model, which can accumulate that together and provide a good response to help the user out. So this is just one of the patterns, architectural patterns, but the thing that I want everyone to remember is think of a multimodality as different sets of information for which you need to give a corresponding text or embedding summary to the user. All right, and to do that, and because large language model is mainly, in most cases, is a text only system, we also have multimodal models, so you have to find a way of converting different modalities to either text only or to embedding only into a form which a large language model can digest to give a response. So, this is just one of the patterns, right? Because here they're not using any embeddings per se, they're just using large language model to summarize the different information modalities. We'll also look at some other modalities which are become really popular, and how they might actually help you develop a robust multimodal system. Alrighty, so let's look at some design patterns that are emerging right now. Now, one thing that I want everyone to understand is multimodality in the RAG space or in the retrieval space is a constantly evolving field, right? So I will talk about three main design patterns that I have observed, which have worked successfully in a retrieval augmented generation space. There are also multiple other design patterns that people have come up with, and it might suit their use cases. But yeah, means if you're building something, please try one of these three, and I'm pretty sure it might probably work out for you. This or one of these variations, essentially. So let's start with that. The first one that we already saw in the architecture section that we discussed is summarize, and then generate. Okay, in this space, essentially, depending upon you might have whatever modalities you're working with. Ideally, I suggest not to work with more than 3 modalities at a time. Let's say you're working with 3 different modalities. It might be image, it might be structured data, it might be text data. We will find either a single LLM or multiple LLMs which could summarize whatever information is captured in each of the corresponding chunks. And that summary, in essence, becomes the index of that information snippet that you have captured. Cool. And we stored it into a vector database with an index linked to a document store. And when a large language model wants to generate based on a question that comes from the user, the retrieval system, based on the question, it tries to find a similarity between that and the corresponding summaries that are being stored. And in this case, you can do a retrieval in any of the ways that we have discussed in the past. It could be an exact search, it could be a full text search, it could be a hybrid search, it could be a lexical semantic search, depending upon your different use cases. And then it correspondingly feeds the large language model different information summaries from different multimodalities, right? And at that moment of time, the large language model will have quite a good corpus of information. Based on that, it can generate output. All right. Now, different organizations do it in different ways. I've seen people who actually fine tune a large language model to do this for them. There are also people, you will find lots of great large language models on the Hugging Face, which are pre-trained to do it, pre-trained to do for audio embeddings, text embedding, structured data embedding. But this is one of the good patterns, quite a simplistic pattern, because there are already summarization is already quite an evolved space in most of large language models. So you should probably see good decent outputs in here. Now, second pattern that probably what we'll discuss is what I call is multi-embedding and then generate. Okay. What does multi-embedding and then generate essentially does is it will depending upon if you have like 2 or 3 or let's say 4 different modalities, you will try to find a corresponding one single embedding for all of the modalities together. Alrighty. So instead of having, let's say, you have, let's say, a picture followed by a text snippet followed by a structured information, and you are chunking them all of them together. This trained large language model is able to compress all of these three information together and create a single embedding for them. So this text chunk essentially gets stored in a this text plus image plus table chunk gets stored together in a database, and the corresponding index becomes this multimodal embedding. And this multimodal embedding is always leveraged whenever your question is asked and you find a similarity between that embedding and the corresponding embedding that gets created of the question. So the thing to remember is what the multimodal embedding does for you is you don't have to like manage multiple embeddings of different modalities. You can have just one single embedding which can help you across all of these 3 different modalities. Number 3, single embedding per modality, then generate. Single modality, again, hopefully quite a simple way of thinking of. Each modality will have its own embedding model. It might be a clip for a image. It might be some other different language model for audios. It might be something else for structured data. And each of them will create a corresponding embedding, and we will have a different embedding stored across all of these 3. So the disadvantage of this is you will probably end up having a huge good big vector store essentially, so lots of spend on the vector databases. But the good thing about it is you are able to cater to the individual niches of different modalities when you're calculating embeddings. So although the processing, so there will be expenditure on the processing side, managing of different embedding stores, managing of different modalities, but the pro is you are able to create a much better balance of different modalities and get the corresponding benefit that is needed when you're actually working with multiple modalities. So that's it. There are also multiple other design patterns that you can think of, but these are the 3 main design patterns that I have observed and I have tried out, and which all of them end up working quite well. But what we'll do is we'll pick one of these and build a project around it. So yeah, let's go. So let's look at a small project. In this project, we are going to develop a multimodal RAG system. We'll first of all develop just a multimodal retrieval system, and then go forward and stack a large language model on top of it. The dataset that we are using is a really nice, nifty little dataset called as fashion product images, and it's on Kaggle. It is a combination of a table which has all the description of a particular product image. It has things like category, subcategory, the seasonal collection from where it is, and a short description of it. And then we have a folder which has its corresponding images. For my convenience, what I have done is I have taken that particular data set and I have reduced it to just 50 records. Okay, so here is what we have done here is we just reduced it to 50 records, which we are calling as a mini fashion product data set, which has just 50 images and its corresponding 50 rows with its category, subcategory, and all the other details. Now, how does it actually look like? So this is how it basically looks like. Like for example, for product display name Peter England Man Party Blue Jeans with a base color of blue, season summer year 2012, you will probably have an image like this. Good. So now that we have a basic understanding of the kind of data that we are looking at, first step is we'll develop a multimodal retrieval system. All right. Now, a multimodal retrieval system, what we are going to use is Clip, a beautiful multimodal embedding pre-trained model released by OpenAI. Kudos to them. Probably it was released very early on when multimodal Gen AI was becoming a thing. Go and check out the paper. Still a great paper to read through. And we are going to use ChromaDB. ChromaDB, a vector database that allows us to quickly vectorize different multimodalities and do a quick vector lookups. So ChromaDB.client, we are reading the style mini.csv, which is a Excel file, reduced Excel file, just 50 records in there. And for each item in the style mini.csv, what we are doing here is we're getting the corresponding image path. Okay, the image path is essentially the row ID in there .jpg, and we are from which we are getting the image. Now we are creating the image embeddings for these. The image embeddings we are creating is we're using the clip model and getting the image embeddings. And finally, we are concatenating all the important parts of the text that we have. We're getting it from, so we are using product display name, master category, and subcategory. And we are using all of these and creating something in Chroma that is called collections. Collections is, in a sense, you can think of it as a multimodal embedding space where it maps different modalities, in this case, an image and a text, into a single embedding space. Cool. Now that one, so here we are doing it for the images and the text. Now that we have done that, our retrieval system is ready. Now in this retrieval system, let's try a few examples. What I want to try and do is I want to just search for things like jeans or a shirt and see if it's able to give me any results, right? Again, remember, ideally something in production will be a much better than what I will show you here because I'm running it on my MacBook Pro. So the example and ability of them is completely limited. But yeah, still a good example to show you how it works. Find similar items. What it does is, depending upon the query that we are sending across, if it's a query's image path, it will take that image, convert an embedding of it, and find a corresponding similar embedding in the collection, in the ChromaDB collection, and give us the corresponding image. If it's a text, same thing. It converts the text into an embedding, finds the multimodal embedding in the ChromaDB, which is closest to that text embedding, and gives us the output. Pretty simple. So now it allows us to this multimodal embedding works across two modalities for us. So you can do things like upload a t-shirt and find similar t-shirts, upload a pant, find similar pants, and so on and so forth. So let's do that. So like in here, what I'm trying to do is I've already done something. I'm trying to look at a t-shirt. So I'm just look at query t-shirt, text, t-shirt. Okay, so I got two t-shirts, one by a male and one by a female. Let's look at something called as just shirt. Let's see what we get. Okay, we don't get any. Remember, again, we might just have one shirt in that database, in the 50 database, right? So first thing that we got is a shirt. That's not bad. Now let's try another example. So what I want to use is I want to try and use an image as a lookup. Okay, so we're going to use probably 49, which is a belt. Okay, a formal men's belt. And when we look at the formal men's belt, it gives me three different things that look like formal belts. Okay, so not bad, right? So it gave me something similar. Now let's look at something else. Let's try something else. We'll look at the record, let's say 39 in the 50 limited record that we have. Nice. So we had the image that we are looking up with is this lady wearing this, I think, pink t-shirt. And okay, now what we have is we have three different women apparel, a t-shirt, something similar t-shirt, and another dress that a woman is wearing. So good. This retrieval system is working quite good, particularly considering that we are using a pre-trained embedding model and we are just working on 50 records, right? Alrighty. So now let's convert this retrieval system into a RAG system. So for a great user experience, the only thing that we need to do is we need to stack up a large language model on top of it, and we have to make sure for any query that comes out of the large language model, whether it might be we are it might be, okay, can you help me with something like this T-shirt or this pen? We should be able to find a corresponding answer in our database, in our vector DB. Similarly, another thing that we have ability that we can now add to our retrieval system is we can allow through the large language model interface someone to upload an image, and that image will go to the retrieval system, find the corresponding text, and give that text embedding in as a context to a large language model, and we will have a better context for large language model to answer. So let's look at it. So we are using GPT-4 Mini. I won't bore you through all the code that I wrote, but a simple call of a GPT-4 Mini, and where the context gets added depending upon the query that is being asked. So the only thing that's happening is the query is being leveraged by the Chroma Vector DB to look up into this multimodal embedding space and find a corresponding embedding which is closer to us. And depending upon whichever is closer to it, it will give us the overall text description, everything around that particular embedding function. And we have this beautiful radio kind of a chat thing that we have created. What we'll do is we'll click something and click and upload something, or maybe we ask something. Ask me about fashion recommendation. Can you recommend me a pant? Okay. Oh, some problem. Let me try again. Recommend me a pink ladies t-shirt. Okay. GLS 221 women's pink t-shirt is a great choice for a stylish and casual look. Okay. So this is not bad. Let's look what a GLS 21 women's pink t-shirt. I think we already saw it somewhere. Yeah, here it is, GLS 21 women's pink t-shirt. So when we search for GLS pink t-shirt, this was the first result that came out. So this was added to a context of large language model, and it gave me that output. Right now, let's do one thing. Let's try and search using an image. Recommend me something similar. Ladies t-shirt recommended GLS 21 women's pink t-shirt is a stylish option that can be easily. Let's clear it and try again, okay? Because I want to make sure that we have a fresh way of looking at what we are doing. Alrighty, let's go again. 3954.jpg. Let's look at the same t-shirt, woman pink t-shirt. We are uploading the image of woman pink t-shirt, and what we'll ask the bot is, can you recommend something similar from your collection? Okay, sure. Based on the options, I will recommend the following. If you're looking for a casual and stylish top, so it understood, right? So I gave it, converted into embedding, and it was able to learn that what we are looking for is probably a woman's t-shirt. The GLS 21 women's pink t-shirt. For a more vibrant option, GLS 21 women purple t-shirt. Okay, W women printed beach kurta. So beautiful. It understood we are looking for women's apparel. It gave us recommendations around that. The large language model has added a good user experience, good human-like conversation capability around it. And remember, we are just working with 50 examples here. Okay, if I convert it, and I will probably do it in one of the later videos on a bigger corpus of fashion or any number of the things, it will give me much better recommendations. So that's about it. That's a really good short tutorial around multimodal RAG systems. Remember, it's still an extremely evolving field. I just showed an example based on an image and a text. You could have video, image, text. You could have multiple 2 or 3 different modalities. But whenever you're building, my recommendation will be always start with 2 modalities. See what are the user experience you're optimizing against, and then build on top of it. So yeah, that's it. This is Shobh signing off. Take care. Chat to you next time. Bye.